Hello everyone. So we'll continue our chapter square and square roots. What we are going to discuss now, we are going to express, or we are going to get some more properties. We're going to express the squares in much simpler form because finding squares of larger numbers is a bit difficult, and then we are going to observe some other patterns. So just to see here has the first concept for today, that is finding the square of a number. Finding the square of 3, it is easy. We can just write 3 into 3 and we know it would be 9. Finding square of 4 is 4 cross 4, that is 16. Similarly, finding square of 5 gives us 5 into 5, that is 25. Right, so this is how we can find the square if the numbers are smaller. What if we have to calculate 23 square? Is it easy for us to just write directly 23 into 23? We need to multiply 23 and 23. Actually, we need to multiply. It's not that easy that we write the answer directly as we were writing for smaller numbers 3, 4, 5, 10, 11 like that. But if we have to find out of 39 or 52, if we have to find out the squares, it becomes difficult for us to write the answers directly. So what we need to do is we need to definitely have to multiply 23 with 23, and it will take time. So is there any other way that you can think around? Yes, there is one way that we can do. 23 can be written as 20 plus 3. Right, 20 plus 3 whole square. We know a plus b whole square is equal to, let us calculate it. It will be a plus b multiplied with a plus b. Now a will get multiplied with this bracket, right, and then b will get multiplied with this bracket. So we get a into a is a square plus ab plus ba plus b square. So we have a square plus ab and ba are same thing, so it is 2ab plus b square. See, this is the formula for a plus b whole square. So whenever we have to multiply two brackets and they have the same numbers inside the bracket with the same operation, so we can just operate them a square plus b square plus 2ab. So here also we can apply the same identity. It is 20 plus 3 multiplied with 20 plus 3. Why we are converting 23 to 20 plus 3? Because to find out the square of 20 it is easy. To find out the square of 3 it is really easy. Okay, so what we will do, we can directly apply the formula. It is a square. A is here 20, right, and what is b here? It is 3. So a square, that is 20 square, plus 2 into a is 20, b is 3, plus b square is square of 3. So we get 20 square is how much? 400, plus 2 into 20 is 40, 40 into 3 is 120, plus 3 square is 9. So you see, 400 plus 120 is 520 plus 9, and it gives us 529. So yes, the number of steps are increased, but the calculation and the solving time is definitely minimized. What we have done, we have calculated the square of 23 not by multiplying 23 with 23, but by writing 23 as 20 plus 3 whole square, and then applying the identity a plus b whole square, that gives us a square plus b square plus 2ab. We used it in this one and we have got the answer as 521. Yes, steps here are increased, but these are really easy to solve and they take very less time. Okay, let's practice some more example. Just to see here, they're asking find the square of the following numbers without actual multiplication. That means if I have to find the square of 39, I don't have to multiply 39 with 39. Without operating this, without actually doing the multiplication, we have to solve it. So to simplify our calculation and without doing the actual calculation, actual multiplication, what we will do, 39 can be written as 30 plus 9 whole square. Right, it can be written as 30 square plus 9 square plus 2 multiplied with 30 multiplied with 9. Why are we doing this? Because we know a plus b whole square is a square plus b square plus 2ab. We have just got this in the previous slide. If you see, we calculated is a plus b multiplied with a plus b gives us a square plus b square plus 2ab, right? So whenever we have to multiply the like this, we can directly apply the identity. So here also we have applied a square, b square and 2ab. 30 square is 900 plus 9 square is 81, we know that, plus 2 into 30, right, that is 60. 60 into 9 is 540. Clear? So now 981 is 981 plus 540. Let us add them. 981 plus 540, we get 1. 8 and 4 is 12. 1 is the carry here. Then 9 and 1 10 and 5 15. So what is the answer that we are getting? 1521. So this is the square of 39. Is that clear to you? What we have done? Express the 39 as 30 plus 9. Also, we could do it in a much simpler way. We could have written 39 as 40 minus 1 whole square. And then we have done 40 minus 1. Then we have done 40 minus 1 into 40 minus 1. We would have multiplied and solve it easily, right? Because we know square of 40 is easy, square of 1 is easy for us. Let us do for 42 now. Let's now do for 42. So for 42, how can we write to find out the square? Without actual multiplication, we have to do it. So 42 square can be written as 40 plus 2 whole square, right? So we will multiply 40 plus 2 with itself. We get 40 square plus 2 square plus 2 into 40 into 2. So 40 square is 1600 plus 2 square is 4 plus, just see, 2 into 2 is 4. 4 into 40 is 160. Clear? Let's add them. 1600 plus 160 plus 4 is 164. In 1600 we are going to add 164. We get 1764. So this is the square of 42. So without doing higher, complex calculation, without multiplying 42 with 42, we are getting the answer, and that is really simple. For these we don't need calculators, we don't have to do it manually. Just by looking on the number we can tell what will be the answer for that. So these calculations are very easy, much easier than multiplying 42 with 42. Is that clear? Let's move ahead now. So the next topic is other patterns in squares. So there is one more pattern that we can see and observe and apply to the questions. So whenever we have to find the square of a number whose ones digit, or I say unit digit, is 5. So suppose the number is a5 in general form. This a can be 1, this a can be 2, this can be 3, it can be any number. This can be 11, okay, this can be 12, like this. So this can be any number. So whenever we have to find the square of such numbers, that means a5 whole square. See, 15 can be written as 10 into 1 plus 5, right? 25 can be written as 10 into 2 plus 5. 35 can be written as 10 into 3 plus 5, right? 115 can be written as 10 multiplied with 11 plus 5. 125 can be written as 10 into 12 plus 5. So see, 10 is same in all, 5 is same in all. What is this? This is the numbers, or I say the digits, except the digit 5. So except 5 we have 1 here. So we multiply 10 with 1. Leaving 5 we have 2 here, multiply 10 with 2. Leaving 5 we have 3 here, 10 multiplied with 3. Leaving 5 we have 11 here, 10 is multiplied with 11. And 5, except 5 we have 12, so 12 is multiplied. So every time, how can we express a digit or a number that has the unit digit as 5? We can express the number as 10 multiplied with the front number. We are naming it as a because it is variable, it can be any number, plus 5. We can write like this. A5 can be written as 10 multiplied with A is C, these numbers only, plus 5, its whole square, because here we have square. Clear? So A5 can be written as 10 multiplied with A plus 5 whole square. So we are going to first solve this, just to see. 10A plus 5 whole square is 10A plus 5 multiplied with 10A plus 5. Square of any number means the number multiplied with itself. So here we have done the same thing. Now first 10A will get multiplied with this bracket. So 10A plus 5, then plus 5 will get multiplied with this. So 5 into 10A plus 5. Okay, just see, 10 into 10A is 100 A square. A into A will form A square. 10 into 10 is forming 10 square, that is 100. Plus 10A into 5 will be 50A. Plus 5 into 10A is 50A. Plus 5 into 5 is 25. So we get 100A square plus 50A plus 50A is 100A plus 25. Okay, now in these two, what is common? 100 is common, A is common. We can write A plus 1 plus 25. So what we observe is, if there is any number that has the form A5, A can be any number, okay, it can be 1, 2, 3, 4, 5, 11, 15, 12, any number. So when we do the square of it, we just have to do it A into A plus 1 into 100 plus 25. So this formula is always going to help us. Here A is the number that is written in except 5. A is what? The number except 5. Clear? Or the digits except 5. So if I have to find square of 15, what will I do? A is here 1. So 1 into 1 plus 2 into 100 plus 25. So 1 into 1 plus 2 is 1 plus 2 is 3. Wait, we have 1 plus 2. Okay, so we had to do A plus 1. A is 1 and plus 1 we have to do. So we get 1 into 2 into 100 and then we have plus 25. So we get 200 plus 25, that gives us 225. So square of 15 is 225. Now I am going to tell you that what we have done in this. Okay, let's summarize this first and then we will move to questions. So before doing some questions, I'll just take some examples. Okay.
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.
So we have observed that if a number is of the form A5 whole square, A can be any number, any digit, then it is expressed as A into A plus 1. Okay, solve this, multiply it with 100 and plus 5. This is what we have to do every time. Plus 5 or plus 25? Plus 25, right? So this is the formula that we are going to use in solving all the questions. Clear? Let us try this with some numbers. If I find out of 125, suppose we have to find out the square of 125. So we don't have to multiply 125 with 125. It is going to take a lot of time. So we know this formula now. Okay, we can apply this to all the questions. So we observe here, leaving 5, whatever is there, that will be our A. So here A is 12. Okay, so putting this in the formula, we get 12 into 12 plus 1. Okay, multiplied with 100. Okay, should we write 12 plus 1? Yes. And then we had plus 25. So just to see, 12 into 13 and it would be multiplied with 100 plus 25. 12 into 13, you have to multiply it, you will get 156. Multiplied with 100, we will get like this, plus 25. So the answer is 15625. This is the square of 125. Let us try it with 35. Okay, suppose we have to find out square of 35. A here is what? Can you think of A? Yes. Leaving 5, what is the another digit that is left? 3. A is 3. So putting in this formula, 3 into 3 plus 1 multiply with 100 plus 25. So we get 3 into 4 into 100 plus 25. 3 4s are 12. 1200 plus 25 gives us 1225. So we directly are getting the square of this number. So if you have any number whose unit digit is 5, so leaving 5, whatever number is remaining, we consider that as A and apply this formula to find out the square of it. Let us apply this formula to some of the questions given in the book. Here is a question. It is asking find the squares of the following numbers containing 5 in the unit place. So 5 is there in every number at the units place. Alright, let us solve it. First one is 15 square. So we know we have to calculate this. We know that A here is 1. Right, leaving 5, A is 1 and the formula is A into A plus 1 multiplied with 100 plus 25. So we know A here is 1 into 1 plus 1 is 2 multiplied with 100 is plus 25. Right, plus 25 we have. Then 1 into 1 plus 1 is 2 into 100 plus 25. We get 200 plus 25. That gives us 225. So this is the square of 15. Second point is 95. Okay, square of 95 we have to calculate. Now we know here A is 9. Okay, so A plus 1 is 9 plus 1. That means it is 10. Clear? So let us put in the formula this one. We will get A into A plus 1 into 100 plus 25. A here is 9. A plus 1 is 9 plus 1, that is 10 into 100 plus 25. We get 90 into 100. So 90 into 100 plus 25. We get 9000 plus 25. So the answer would be 9025. The square of 95 is 9025. Is that clear? What we have done? Leaving 5, take the digit that is left or the number that is left. Here only it is one digit, that is 9. So A plus 1 is 9 plus 1, that is 10. Putting in this formula, 9 into 10 into 100 plus 25. So it becomes 9000 plus 25, that is 9025. Let us do with 105. So for 105, which is the third part of the question, we know what is A, right? Leaving 5, what is left? A is 10 here. And what is A plus 1? It is 11. So we'll write A into A plus 1 into 100 is equal plus 25. So A is 10. A plus 1 is 11 into 100 plus 25. So 10 into 100 becomes 1000. So we get 11,000, right, plus 25. So the answer is 11,025. This is the square of 105. Directly we got the answer. We did multiply 105 with 105. Fourth part, it is 205 square. So except 5, what you are left with? It is 20. So here A is 20. A plus 1 is 21. Right, so putting in this formula, we'll get 20 multiplied with 21 multiplied with 100 plus 5. So just to see, 21 into 2 is 42. So we get 420 multiplied with 100 plus 5. We get 42,000 plus 25. It is not 5, it is 25. So we get 42,025. 5. This will be the square of 205. So what is the formula? A into a plus 1 into 100 plus 25. So every time we are going to add 25 in the number and we are going to do a plus 1 and 100. How to identify a? Just leave 5, except 5, whatever the number of digits are left, you are going to take that as a. Clear? So here except 5, 20 is left, so we are taking a as 20. A plus 1 became 21, and putting the values in the formula, you're going to get your answer. I hope this gives you a clear idea. If a number is there, any number that is lasting or that is ending with the digit 5, we can use this formula to find it out. So this is also one of the pattern that was observed, right? And it is really helpful in solving the questions. And it is minimizing our calculation. Also, the complex calculations are now gone and we are just doing simple calculations. We can do it orally only. We don't have to do it, manually, on a paper. It will be easy for us to do. Clear? Okay, so the next topic that we are going to start with is Pythagorean triplets, right? You might be aware of Pythagoras theorem. If not, let us discuss here. Okay, just to see, consider square of 3, square of 4 and square of 5. What is the relationship between these three numbers? We can write 3 square plus 4 square equals, let us find it, 3 square is 9, 4 square is 16 and it is 25, can be written as square of 5. So we can write 3 square plus 4 square is giving us 5 square. That means sum of squares of two terms is giving us the or is equal to the square of third term. Let us try with some other triplets. Suppose 6, 8 and 10. 6 square plus 8 square. Let us try. 6 square is 36, 8 square is 64. Adding them we get 100, which is a square of 10. So square of two of the terms, the sum of squares of two terms is giving us the square of third term. These are known as Pythagorean triplets. Why triplets? Because they are 3 in number. Is that clear? So we know that for any natural number m which is greater than 1, okay, this applies to the number which are greater than 1, we have 2m whole square plus m square minus 1 whole square equals m square plus 1 whole square. So these three are the general form of the Pythagorean triplets. Let us identify how. Just to see. So every time you are given three numbers, you can equate them to 2m, m square minus 1 and m square plus 1. Just to see. So here we have 6, 8, 10. So keeping 2m equal to 6. M will be equal to how much? 3. M is equal to 3. Now we can find the others, right? M square minus 1. M square minus 1 will be 3 square minus 1, that is 9 minus 1, 8. Right? You got 8 and from the next one you should get 10. Just to see here, 3 square plus 1, right? What will you get? 3 square is 9 plus 1, it is 10. So we are getting the third one also. Clear? So like this, whenever three numbers are given and it is said that they are Pythagorean triplets, or 1 is given, 2 is given, or we have to verify that they are Pythagorean triplets. If all three are given, we can use this general result to find. Clear? Keep this in mind. These are the three Pythagorean triplets. Is that clear? Now they are saying write a Pythagorean triplet whose smallest member is 8. So smallest member, three members we know, 2m, m square minus 1 and m square plus 1. 2m is the smallest one. Right? We know that smallest one is 8. So keep 2m as equal to 8. What will this give m as? M will be equal to 4 if we divide both the side with 2. Just to see, here it will get cancelled and it is giving us 4. So m is 4. If m is 4, we have to write the triplet, right? So we just know one, that 2m is equal to 8. We know one member, that is 8. We are left with the two other members. Now we will do m square minus 1. Let us do m square minus 1. What is m? 4. So m is 4. 4 square minus 1. 16 minus 1, that gives us 15. So what is the second member? 15. Let's find out third. M square plus 1. So we have 4 square plus 1, that is 16 plus 1 gives us 17. So it is 17. Is that clear? Now we can verify your answer also. See, 8 square is 64. 15 square is 225. If we add them, what we get? 5 and 4 is 9. 6 and 2 is 8. And then we have 2. We are getting 289, which is a square of 17. Right? So the square of 2 of them is giving us the square of 3. They are Pythagorean triplets. So just by knowing one number, we are able to find out the rest too. Is that clear? Let's move ahead now. Here is another one which says Pythagorean triplet you have to find and one member is 12. So let us consider 2m as equal to 12. Now m will be equal to 12 upon 2, that gives us 6. If m is 6, one member we know it is 12. M is 6, then m square minus 1 and m square plus 1 will give us the other two members. M square minus 1 is 6 square minus 1. Here 6 square plus 1. So here 36 minus 1 is 35. 36 plus 1 is 37. So we have 35 and 37. These are the three Pythagorean triplets. So just by knowing one of the member, we can find out the rest also. Is that clear? Now, there might be a question that arises or that might be arriving by having a look on the video, that why I am always taking 2m equal to 12. So it is not so. You could have taken m square minus 1 as 12 and m square plus 1 as 12. Right? Until and unless it is written the smallest, we can take it any. So suppose if I would have taken m square minus 1 as 12, what will I get m square as? 12 plus 1 is 13. So when I find m, I'll get square root of 13 plus minus square root of 13. So is this an integer? This is not an integer. Here m is an integer. When we discussed the definition, we discussed for all the integers that are greater than 1. Right? Similarly, if I would have taken m square plus 1 as equal to 12, I would get m square as 12 minus 1, which is 11, and m will be equal to square root of 11. Right? So this is also not an integer. Clear? So we say that 2m will be equal to 12. That's why we took 2m equal to 12, because by putting this we get m as an integer, which is a 6. Clear?
Now, subscribe to Bright Tutee course at ₹1 per day only. Download Bright Tutee app from Play Store and get the online courses prepared by competent and experienced teachers for different education boards of classes 6 to 10. Bright Tutee courses are available for the subjects of Math, Science, Social Science, English and Hindi in English and Hindi medium. Bright Tutee follows 3-step approach, that is learning, assessment and exam preparation. In learning, topic-wise video lectures with explanation of concepts and discussion of textbook examples and questions are available with the solutions. In assessment, topic-wise online MCQ test, practice assignments and chapter-wise question bank are available with the solutions. In exam preparation, previous year's question papers, sample papers and model test papers are available with the solutions. Sign up today on Bright Tutee and avail your courses at affordable prices.